All right, so this is where we left off yesterday. Now, I told some of y'all if you wanted to try it and go on and see if you can figure this one out, go for it. Now, when we look at this here, something is different than the one previously, yes? Because all the ones we've had up to so far, the x and y have been on what? The same side, haven't they? So if I'm going to solve this, well, it's going to be nice if I have the x's and y's on the same side of the equation. So our 7y minus 6 equals 3x. So we have this here. So we want to get x's and y's on the same side. Well, to move the x's over to the other side, I can do what to both sides? I can subtract the 3x from both sides. Now I'm just going to put it in the middle because I don't have space to put it to the side. But is it... So here, 3x minus 3x, these will cancel. Well, is 3x in common with 7y or the negative 6? Are they like terms? No, because for it to be like terms, they have to have the same variables or no variables. So this here wouldn't. So we can just say 7y minus 3x minus 6, because there's no like terms with any of them. Now the other one we have is 3x minus 30 equals y. Well, y is on the wrong side here also, isn't it? So we need to move it to the other side. Well, is y positive or negative? So we would minus it because y minus y, these here cancel out, yes? So what I get is, do we want to put the y in front of the 3x or after the 3x? How do we want to write these? Okay. Because y minus y would give us 0, yes? And that's what we wanted on the one side. And we moved it to the other side. So now that I've kind of rewritten these, I have x and y on the same side, yes? Does it matter that the number's with them? Well, not really. I mean, we could move the numbers over so they're equal to a number, but it's not going to change anything. Because again, what are we wanting to do? We're wanting one of the variables to cancel out. And once we get one of the variables to cancel out, then what? We solve for whatever's left, yes? Because if we cancel the y's out, we would solve for. If we canceled the x's out, we would solve for. Now looking at these two here, do I have a variable that's by itself already? Or I mean a number in front of a variable that's the same. So I have 7y and I have negative 1, negative 1y. Here I have negative 3x and I have 3x. So is one of the variables already the same? Well, the x is, yes. So I can put them over the top of each other so that we can use our elimination. Now, whenever we do this, we want to make sure that the variables all line up, the numbers and variables terms line up over the top of each other. Because it's going to be easier to work with. So our like terms, well, we have y over y. Those are like terms between the two equations, yes? So we have them lined up. The x's and x's, we have them lined up, yes? Now we have two places where there's numbers. We have zeros that are lined up, and that's fine. Numbers that are lined up. So across all four terms, we have all the like terms lined straight up and down, yes? Okay. Now looking at this here, would we add the two equations or would we subtract the two equations from each other? Add, why would we add? Signs are... You're right, we do add when the signs are opposite of the term we want to eliminate. So here we're wanting to eliminate x because we do have 3 and 3. The numbers are the same, but the signs are opposite. When the signs are opposite, we add. When the signs are the same, we subtract. And when we do this here, 7y plus negative y, 7y minus y would give us 6y. Negative 3x plus 3x. Those cancel out. Negative 3 plus 3 is 0. Negative 3 plus 3 is 0. Negative 6 plus negative 30. So that would be negative 36, yes? And this here equals what? 0. This here equals 0. So now that we did that, do we have a variable by itself? I mean, we just have one. I mean, there's two of them, but we just have one of them there. Any questions on this here so far? So now what do we need to do? We need to solve for the value of what? Y. We need to solve for the value of y. And what can we do first to solve for the value of y? I would agree. We're going to add 36 to both sides. Well, negative 36 plus 36 will cancel. And that'll give me 6y is equal to 36. And then what can we do? We can divide both sides by 6. So if we do this here, guys, all the way down. Yep. Thank you. We get y is equal to 6. So we found the value of y. Y is equal to 6. Any questions on this here? So what do we do next? We've got to plug it back in. So we can go back up to the top. It doesn't matter where we go. I'm just going to go all the way up to the top. 7, and use this here. 7y minus 6 equals 3x. And we know y is equal to what? So we can say 7 times 6 minus 6 equals 3x. 7 times 6 minus 6 equals 3x. So 7 times 6 is 42. Minus 6 equals 3x. Well, 42 minus 6 is 36. We would need to divide both sides by 3 to get x by itself, because 3 divided by 3 would give us just x. So the final point would be not 6, because x always goes first, so it'd be 12, comma 6. So the solution for this here would be 12, comma 6. That would be our answer. Questions on this here? Any questions on any of this here so far? We good with this here? Yes? Now, if I were doing this and I didn't have it, and I can do this in any method I wanted, graphing, substitution, or elimination, I would be more inclined to do substitution than I would elimination. Because with substitution, we need what? We need a variable by itself, yes? Then the top equation already set up in that form. That's why I would use substitution, because it's already set up in a way that I can use it pretty easily. We can just plug it in. And we would get the same answer. Okay. Now we're going to look at the other type of elimination, this here. Now this here is slightly different. We're going to have to do something a little bit different for this here. Now when I look at these two equations, again, well, x and y are on the same side of the equation, which is nice, because we're not going to have to do anything to manipulate it or change it in any way, shape, or form. But when we look at this here, would it be, are the x's the same? Is the same number in front of x? So the same number's out in front of x. How about y? Because x has 10 and 5. Y has what? 3 and... So what we're going to have to do is we're going to have to manipulate one of these equations or both equations so that the values in front of x or the values in front of y are the same. Now, looking at these two here, do we want to eliminate x or y? Because we just need to pick. So this one here, we've chosen to eliminate y. That's our choice. So 3y and 6y. Now, what I'm looking at is trying to see how can I make 6 be the same as 3 or make 3 be the same as 6. Is there anything I can do with, so 3 is smaller, we'll always work with a smaller number. Is there anything I can do to 3 to make it be the same as 6? Or is there anything I can do to 3 to make it be 6? What with 2? What can I do? What with 2? Right, 2 times 3 is 6. So if I multiplied 3 by 2, it would be 6, and then we would have the same thing, yes? So what we can do, and what we're going to do, is I'm going to take the top equation with negative 10x plus 3y equals 1, and I'm going to multiply the entire equation by 2. And what this is, and what they call this in mathematics, is a scalar. And we're scaling the problem. We're not changing anything about the numbers. We're just increasing everything by a factor of 2, a scalar of 2. So we have to distribute. Well, 2 times negative 10 will be negative x, plus 2 times 3y would be equals 2 times 1 is. So this here is our new equation. We've multiplied everything by 2, yes? So this top equation is the one we use. So I'm going to put a line through it. You don't have to draw a line through it, don't. I'm just drawing it there so that we can kind of see this is gone. Because we're not looking at that equation anymore because we did what? We multiplied it all by 2. So our other equation we're looking at is this equation number 2. So equation 2's y values is 6y. Our new equation's y value is 6y. Are those the same now? Well, yeah, now I can use elimination to cancel the y's out, can't I? Because they're the same. So I can put that underneath. So we have negative 5x minus 6y equals 23. Now those values of y are the same, yes? So would I add or subtract to eliminate y? Why would we add? Why would we add? They're opposite because I have positive 6y and negative, because positive 6y plus negative 6y is what? 0. This works out to be 0. And that's what we wanted to have happen. Yes, we wanted those two cancel out. Now let's look at the other one. Negative 20x plus negative 5x. Well, it's going to be what? Negative 25x. 2 plus 23. So once we did this, and I'll rewrite it so they're a little bit closer together, negative 25x is equal to 25. Any questions on how we got to this point here? So anything we've done up to this point, I mean, we've only had one little change, isn't it? We had to what? We had to scale. We had to multiply one of the equations by a number, so we got a variable to be the same. And now we have it as x negative 25 equals 25. So what do we need to do? Well, solve for x. Divide both sides by negative 25, and what does that tell us? X is equal to what? Well, 25 divided by 25. Anything divided by itself is 1. And it would be negative, because a positive divided by a negative is a negative. Any question about how we found the value of x? We good with this here? So we found out x is equal to negative 1. Now I'm going to, okay, I can't erase everything. I'm going to erase most of this here. So we have this here. We have this equation, and I'll leave those parentheses. I said the value of x is equal to negative 1. Erase that. How many equations do I have to choose from on which to plug x in to find the value of y? You can put it right there. I actually have 3. Because we do have equation number 1. Because we have this here. This is equation number 1. This here is equation number 2, yes? Isn't this equation also true? Well, actually it'd be, sorry, this one. These here are actually the same thing. But I could use this one here, the one that I multiplied everything by 2. We could use that one also because it is true. It's the same as equation 1, except everything's been multiplied by what? 2. It would be the same thing. So it doesn't matter which one of these 3 I use. Any one of them would work. Any one of them will give us the same value of y. Which one do we want to use out of these 2? Let's pick one of these 2 because I erased the 3rd. Second one. So we have negative 5 times. Well, the x is negative 1 minus 6y equals 23. So we're going to solve for the value of y. Now we plug negative 1 in for x. Well, 5 times negative 1 would be 5. Minus 6y equals 23. Now at this point here, we want to get y by itself. So we will subtract 5 from both sides. And when we subtract 5 from both sides, well, 5 minus 5 here, this will cancel, giving us negative 6y equals 18. 23 minus 5 would give us 18. Huh? Yes? 23 minus 5? Because 19 plus 5 is what? Because 1 would give us, because when we look at this here, yeah, the way I look at this here for the subtraction, so if I take 23, well, 3 taken away would dig me down to 20, yes? And how many have I left out of 5? 2, which pulls us up to 18. So I always try to go to the nearest 10 and then work from there. And then lastly, we're going to divide both sides by negative 6. Well, positive divided by negative will be a negative, yes? See you tomorrow. 18 divided by 6 is negative 3. So the answer for this here is negative 1, negative 3. This here would be our answer. Questions on this here? All right, we ready to look at another one of these? Okay, so looking at this here, I have x minus 3y equals 24, and I have 3x plus y equals 12. Now, looking at this here, I mean, between x and y, there's not going to be any real difference. One's not going to be harder than the other for this one here. They're going to be about the same. So do we want to eliminate x first, or do we want to eliminate y first? Why? So if we look at the y's, well, we have one of them is 3y, the other is just y, yes? Now, when we do this here, when we kind of make them try to be the same, it's always easier to make them bigger instead of trying to make them smaller. So looking at this here, well, 1y is the smaller one. So we're going to see, what do I need to do to y to make it be 3y? So what do I need to do to y to make it be 3y? So I'm going to be adding, because we're going to be times it by what? So what times y will give me 3y? 3, because 1 times 3 is 3. Huh? it is, there's probably, we'll see if we finish everything up. So you'll definitely be able to get started on it, but we'll see if we'll need to do a few more tomorrow. We'll see. At least, I'll answer that here in a minute. So we'll multiply the bottom one by 3. Or multiply the bottom one by 3 because we want the values of y to be the same. Now we have to distribute this through. 3 times 3x will give us 3 times y will be, and 3 times 12 will be 36. Okay. So we used this already, and I'll kind of circle it. So the one that we're really going to be still using for elimination is the first one, because we can't use the one to eliminate with the one we just used to get there. So I can't use addition or subtraction with our 3x plus y equals 12. There's one thing, the y's aren't the same. It wouldn't help us. So I'm going to grab the one up top because the y values are the same now, yes? I mean, well, the signs are different. Because the signs between these two y values are different, aren't they? But does that matter? No, we just wanted the number to be the same. Now, would we add or subtract these? We would add because these signs are different. Because when the signs are different, we add. When the signs are the same, we subtract. And the way we can look at it is, we chose what? We chose to eliminate y, yes? So positive 3y plus negative 3y is 0. So the one way we can see is look at them. Okay, the numbers are the same. If I add them, does it become 0? If it does, then it works. If it doesn't, let's see. If we subtract it, would it become 0? And that's kind of what we're doing, is trying to make it 0. So we can see 3 plus 3 or 3 minus 3. See which one becomes 0. And then we'll do it with the rest. Now 9x plus x would be 10x. Would be 60. Because 36 plus 24 would be 60. 6 plus 4 is 10. Carry the 1. 3, 4, 5, 6. Now the last thing we need to do is do what? Divide both sides by 10, which will tell me x is equal to... We're almost done. So x is equal to 6. I'll go on and write that up here. So we found that out. So we went through and solved it, and we found out the value of x a little bit further. And found out the value of x is 6. Now our last thing is we've got to do what? We've got to plug it back in. We have to plug it back in. Now it doesn't matter which one we choose, because we could pick, let's see here. So I could pick this equation here, or I could pick one of the two it gave us to start with by plugging x equals 6 into one of them. It doesn't matter which one I choose. I just have to pick one. And we're solving for the value of y. I'll choose the bottom one. Not this one. This one here. Y is by itself. Why not? Yeah. Why not? That's all right. My wife doesn't find me funny either. I find myself funny, so that's all that matters. 3 times 6 is?
Oh, 3 times 5 is...
3 times 5 is 15. Yes. You're good. That's what a calculator is for, right? Or my head, one of the two. 18 minus 18 is 0. 12 minus 18 would be what? Y'all know? What's 18 minus 12? 6? That would be negative. So that's somehow how I do it. I just flip it the other way, see what it is, and then go there. so negative 6. Well, x was 6 and y is negative 6. So this point is 6 comma negative 6. And that's our answer. Questions on this here? Okay. Okay. Now, I'm going to stop here because